Basics of functions and their graphs. Graph the given function f and g in the same reticular coordinate system. Use the integer values of x given to the right of the functions to obtain ordered pairs. Describe how the graph is related to the graph of f. Okay, we'll start with the black color. Okay, so we plug in a 0 here. Okay, well, if I say, basically this is going to be the square root of 0, which is just 0. We say the square root of 1 is equal to 1. The square root of 4 is equal to 2. The square root of 9 is equal to 3. Okay, well, g over here is x plus 8. So it's going to be whatever the previous one, but plus 8. So 0 plus 8 is going to be 8. Then 1 plus 8 is 9. 2 plus 8 is 10. 10 plus 3 is 13. Oh, sorry, 8 plus, 8. So we say 8 plus 3 is 11. Okay, so let's try graphing this out. Okay, so the first one's going to be a base one, so it's going to be just point there in the middle. Then we have a 1, 1. Then we have a 4, 2. A 4, 2 right there. And then we have a 9, 3. A 9, 3 right there. So it looks like like that. All right. So the next one is going to be moved over 8. It's actually going to move up 8. So we have a 0, 8. A 0, 8 would be up here. Okay. Then we have a 1, 9, which would be right there. And then we have a 4, 10, which is right there. And then we have a 9, 11, which would be right about there. So I draw a line through it, just like that. And sure enough, what you see is that went up 8. That went up. Y went up 8. Okay, and that's exactly what you would predict given that you added it on the outside of the parentheses or the outside of the radical. So that actually worked out pretty nicely. Okay, I gave you numbers that I knew would work out nicely, but in real life you might have to deal with some ugly numbers. Okay, use the vertical line test to determine if the following graphs are a function of x in the graph. All right, so the vertical line test is basically what it says. Basically what it says is that if you drew a vertical line, like and you pulled it along, or if you drew an infinite number of vertical lines, that's also another way to look at it. If it only hits it in one place, then it passed the vertical line test. So this one right here, it passed. Now, there's no vertical line that I could draw through there that would hit it in more than one place. So it passed the vertical line test. So it is a function. That's basically how it works. Now conceptually, basically what that means is that for every x value, which is a vertical line, it only hits the function in one place, which means it only has one y value, right? So each one of these vertical lines is an x value, and where they hit, right, that would be the y value. Okay, so again, for every x value or for every vertical line, there's only one. It only hits once, so it only has one y value. Same thing on the next one, right? If I draw an infinite number of vertical lines here, right? Again, this one passed. It passed the vertical line test. So therefore, this is a function. And if I could, I could draw like a vertical line across here, just drag it across. Same kind of concept, right? Same thing. Let's try this one. Whoops. Here's the problem with this one. This one did not pass. It did not pass the vertical line test. Therefore, not a function. Did not pass, not function. Okay, so what that basically means is, for every x value in this one, there were some x values that had more than one, right? So you can see like this line right here. That's supposed to be vertical, by the way. I know it's not technically vertical. But you can see that vertical line, that x value, actually hit it twice. So for that x value, there are actually two y values, and therefore this is not a function.